Hi and welcome to Best in Tesla. We have talked a lot about the true cost of ownership over a car's lifetime. We know that the BEV, the fully electric car, will be about 3 times as cheap as an equivalent ICE car over their lifespan. But we have not talked a lot about the true emission of a car's lifespan. People just talk about how much comes out of the tailpipe, if like the petrol is just magically there at the gas station. But it is not. So we are talking about the fuel extraction, the refining, the production and the transportation. Because when people talk about, but batteries need a lot of materials from the ground, and when people talk about the pollution of the EV, they are taking mining and everything into account for the EV, but they rarely take everything into account when they talk about the ICE car. I have made a similar video before, but now we have a new study out from T&E, and their paper aims to provide a comparison on a system level the resources needs of a fuel-powered versus a battery-powered car to answer the underlying question, which has less of an impact. And the T&E is the European Federation for Transportation and Environment, which is founded from various institutes like the European Climate Foundation, European Commission, Climate Works Foundation and many more. But this is just to say the research is not founded by anyone who has a hidden agenda, other than getting a cleaner future. It is not like Chevron making a study of how great diesel is. This is just an environmental federation and a collaboration between 23 countries. Just to say, I do trust the source here, and they do put a big nail in the coffin for the debate between ICE and EVs. So let's check this nail out and let's dive right in. Let's start with the part of the research that talk a bit about the demand of EVs and batteries here in Europe. T&E thinks that the demand for batteries for the transportation sector is going to be about 700 gigawatt hours in 2030, because that would be roughly enough for about 8 million electric vehicles. So by those numbers, T&E expects the European car market to be about 54% EVs in 2030 and 21% by 2025, where they talk about 200 gigawatt hours of battery demand. Here I do disagree a bit. I do think the demand will be much higher. We will not only have 50% EVs in 2030, this is my guess anyway, but T&E follows the level of ambitions of the European car CO2 emission reduction targets, so that is totally fair, but I still think this will happen much faster. But the EU should not be selling any ICE car by 2035 to get to the targets of the European Green Deal and decarbonize road transport by 2050. And thanks to the European Battery Alliance that was established in 2017, we are getting a great big push for battery manufacturing here in Europe. Tesla has also got 1 billion euros from the European Battery Alliance to build their battery factory in Berlin, and many others has also got funding for their battery factories. So the 200 gigawatt hours in 2025 seems very, very low if we take Tesla's targets into account. Their battery factory in Berlin that they are building as we speak, that they expect to be producing about 100 gigawatt hours already next year, and expected to produce about 200 to 250 gigawatt at a full capacity, which I do expect will be before, or at least in 2025. So T&E expects only 200 gigawatt hours of production in 2025, but that is what Tesla will make all by themselves. In 2025, I do expect Berlin factory to be running at full capacity, and that will be at 2 million cars a year, which they will all feed with batteries made at the Gigafactory in Berlin. So that factory alone will probably deliver as much as T&E is talking about. So I do believe we will be at a much higher level at that point, because Tesla is not doing this all by themselves. Everyone is pushing for making EVs and making more batteries. So I do think the numbers of gigawatt hours hours demand is very low in their paper, but that of course has nothing to do with the environmental impact that this report is talking about, but I just wanted to mention this since this will make the impact even greater. And the TNE does know this, as they do mention that Tesla is aiming for the 250 gigawatt hours and thus accounting for close to all the growth beyond 2025. It is likely that other battery manufacturers will also increase their ambition levels further into the 2020s. So they are aware of this, but they are not following the gigawatt hours but following the EU CO2 targets for their demand numbers. And TNE does think that already here in 2021 the supply of batteries should meet the demand here in Europe. So that's pretty cool that Europe should not be battery constrained after 2021 compared to the expected demand anyway. And the EU will also benefit a great deal from making the whole transportation system electric, as Europe has to get a lot of fossil fuel from overseas to meet demand. But when we are converting to fully electric cars, we do have enough materials in Europe to become self-sufficient. And that will also make a big difference in the amount of CO2 emissions that the EV will make over its lifetime, because we don't have to import all the materials as we do today. The current dependency in Europe on crude oil for cars dwarf all future dependency on battery raw materials. Although the EU is currently high dependent on both oil import, 96% of crude oil supply, and battery raw material, about 50% for nickel, 86% for cobalt, and 100% of lithium. But the dependency on oil is several orders of magnitude higher than the one for metals, even when we look at 2035, in a scenario when all new cars are BEVs. As Europe develops some of its domestic resources, notably lithium, the dependency will decrease. Oil consumption for passenger cars in the EU and the UK is equivalent to 1.3 billion barrels of oils, which, if we imagine them placed on top of each other, would become a tower of 1 million kilometers in height, or close to 3 times the distance between Earth and the Moon. On the other hand, the total battery demand for the primary raw materials would account for about 1.1 million tons in 2030, or a single cube of 71 meters large. That is quite the difference in use of resources here. For a medium-sized EV with an average battery composition, TNE takes the weight average of the battery chemistries placed on the market in 2020 and a 60 kWh capacity. Those materials account for around 160 kilos. The remaining weight of the battery cells is mainly composed of electrolytes, binders, separators, and battery casing. But reusability of the battery is the real game changer here, since about 95% of all the materials in a battery can be reused. So we can't just say that the mining for the materials for one car equals 160 kilos, as many do. No, it's only about 30 kilos that one car will waste of these materials. So those 160 kilos of materials mined up for that one car is actually material enough for the next 4 cars as well, or what they will lose anyway, or use of resources. And of course we need companies that do the recycling, but as we already see, companies that are in the battery business is already doing this, like Tesla. And Volkswagen also has a pilot plant going right now, and we see more and more companies like Redwood Materials coming along, because this will be a huge business in the future. So I'm not worried about, oh, we need to invest a lot in recycling, how will we do that? Because many will want to do that, because this will make billions of dollars, because recycling will become the new mining in 10 to 15 years. So the available amount of materials will also be much higher than people think, and maybe even TNE, because if we believe Tesla's numbers, we will have about 1 terawatt hours of batteries available for recycling in 2025 from all kind of product, I'm guessing. But that is enough for about 13 million EVs on a global scale, not coming from mining already in 2025. And I still hear people say they can't recycle that and blah blah blah. But this is not something in the future. We are already doing this today. In 2019, recycling capacity in the EU alone was around 33,000 tons per year, with 15 battery recycling companies. So it's already a big business today, but it will just become massive in the future. But as batteries also gets better and better over the next decade, we will also need less and less materials in every car, because the energy density will get better. So we will get more with less. So we also need much less materials in 2030 per car as we do today. And the more and more renewable energy we will get in every country, the better the EV CO2 emission will get. Just remember, where we are now is how bad it will ever get. It will only become better. But burning fossil fuel will always hurt us and our planet. And T&E does set a recommendation for the EU to have an EU-wide phase-out date for the sales of ICE cars no later than 2035. Many countries are already doing this and are setting their targets even earlier, like Norway already in 2025, and countries like Denmark, Germany, Ireland, and many more by 2030. So for companies like BMW to think that they will make ICE cars until 2050 is just wishful thinking. Not only are they going to be banned most places on the planet by then, but the EV will become much cheaper to buy this decade already. So no one wants to buy them at the end of this decade, in my opinion. So this will happen not just because environmental organizations recommend it and because countries will ban it, but simply because it will be the logical choice. Just look at Norway. When they put a lot of taxes on the ICE car, everyone went to buy EVs, and they will already be at 90% BEVs in 2021. But when EVs will become cheaper, not by taxing or incentives, but just cheaper to produce, nobody wants to buy the polluting inferior product anymore. So the crucial difference between fuel used in conventional cars and battery used in EVs is that the fuel is burned once, whereas the battery materials can be reused and recovered in a circular loop to produce more batteries. Once a battery is too degraded in the performance and its state of health falls below a certain threshold, typically 70 to 80%, it is considered that the battery has reached the end of its life and would then either go to a second life application such as stationary storage or recycling. When we take into account the recycling of the battery cells materials and the majority of the metal content is recovered, T&E calculate how much is consumed or lost during the lifetime of an EV. Under the proposed 2030 recycling recovery rate targets, around 30 kilos of metal would be lost, as I mentioned. Over its lifetime, an average medium ICE car burns close to 17,000 liters of petrol. When putting into perspective the total amount of key resources that are consumed and which cannot be recovered, they show that the weight of petrols and diesel that are burned during the average lifespan of a vehicle is around 300 to 400 times more than the total equivalent of battery cells metals lost. 300 to 400 times, not percentage, times. The lifetime fuel consumption of the diesel and petrol cars would be equivalent to a tower of oil barrels stacked end to end, which is 70 meters high for diesel or 90 meters high for petrol, approximately the height of a 25-story building. If compared with a cube made out of the metals in the battery cells, with recycling taken into account, the cube of metal which are lost goes down to a 25 centimeter, approximately the diameter of a football. Electric cars outperform diesel and petrols in all scenarios, even on a carbon-intensive grid such as Poland, where they are about 30% better than conventional ICE cars. today. That is the worst case scenario today. In the best case scenario, an EV running on clean electricity with a battery produced with clean electricity, EVs are already today about 5 times cleaner than conventional ICE cars. The evidence shows that the electric cars powered with the average European electricity repay their carbon debt from the production of the batteries after just over 1 year, as we have heard many times before in other studies, and saves more than 30 tons of CO2 over their lifespan compared to the conventional equivalent. And electric vehicles that do high mileage, like shared vehicle, taxis, or ride-hailing services, saves up to 85 tons CO2 over their lifespan compared to diesel. And remember, electric cars with their generated braking don't really use their brakes either. And when we are talking about air pollution, the very small particles coming from the brake dust is very dangerous. That is a big part of the air pollution in our cities. That is what you see on your rims and why you get dirty rims, where my Tesla never gets dirty rims because I don't use my brake much. So just that little tiny thing saves lives every year. So we will save a lot of CO2 and get much better air quality and save millions of lives on a global scale, and only have to use about 300 to 400 times less resources from our ground. And they even have a little piece in their research about the efficiency of battery electric vehicles versus fuel cell electric vehicles, where you can clearly see that the BEV is the way to go. The overall efficiency of the BEVs is today 77% compared to the hydrogen that is only about 33%. And they don't expect that to be more than 42% in 2050, 30 years from now. Like Elon said, fuel cells are equal fuel cells, because we have to remember hydrogen is not a resource. We have to make that energy out of something, and that is very energy heavy. So there might be a lot of great use cases for hydrogen, but I don't think it will ever be in our transportation sectors. And don't even bother looking at diesel and petrol. They're just jokes when it comes to efficiency. And don't forget that the true cost of ownership of an EV is much cheaper, and the EV themselves will become cheaper. And remember, it is not just you and me that will get these savings when buying an EV instead of an ICE car. So will every company, every taxi company, every bus company, and so on. So you will save money, your companies will save money, your cities will save money, your state will save money, and your country will save money. And this is not just for the next 5 years, this is forever. Going forward, the electric transportation sector will be much cheaper than our current ICE transportation sector. So there are really no reason for not doing this. None, sip, nada. It is much better for the environment, our planet, the climate, our air pollution in the city, and for the economy. It's a win-win-win. Win-win-win-win-win. And thank you for watching. And until next time, take care out there and be nice.